Equivalence means whether DFA and NFA are having equal power. Are they equivalent to each other? So we can say that yes, they are equivalent to each other and they have the same power. Now, what do you mean by power of a machine? Can we say DFA and NFA are the machines? Yes, they are the machines. Now, how we will indicate that the particular machine is very powerful? So, anything is powerful if it is able to do many things efficiently, right? Now, what is the purpose of DFA? So, we have just seen that DFA is acting as language recognizer, right? Language acceptor, then sequence recognizer. In short, it is a mathematical or finite state machine which is purposefully designed for language acceptor, right? Now, if the power of DFA as a language acceptor, then what is the power of NFA? So NFA is also acting as language acceptor. Now the question arises, if both are acting as, then what is the requirement? Now NFA are also, if we are drawing equivalent and DFA for NFA, once again repeating, I am drawing one, for example, NFA. So our NFA is Q0, 0, Q1, 0 with Q1 and reaching to Q2. And there is one more transition here, Q2, like this. Is it a NFA or DFA? Just check, as I have told you. So this is a NFA. Why? Just take outgoing arrows from any state. Suppose we are considering this Q0 state, outgoing states are indicates that it is a NFA. Now, if I want to check what is the power of this NFA or what is the purpose of designing this NFA, so how I will check here? I will say how I will check what is the power or what is the purpose of this NFA. So, what is a simple way? I will move from Q0 to Q1 with 0. Everybody agree? Now, I will move from Q1 to Q2, which is a final state with 0. This is one way. But if I go from Q0 to Q1 with 0, okay, after reaching to Q1, I am available with more path here, but with the another symbol. So even though I get here 1, okay, then also this is acceptable because with 1 also it is reaching to final state. Now if we not consider this part, now this is a DFA, right? Because with current state, current symbol, it is reaching to only single state. With current state, current single symbol reaching to single state. Current state, single symbol. Now if it is 0, then it will become the NFA, but it is 1. So this is now a DFA, right? Now, what language will be acceptable? Minimum 2. This is clear, I hope. These 2 are the strings which are acceptable by any other string is acceptable to this DFA. Sorry, NFA. I don't think. Why? Available in this, except this part, because if we want to show the acceptance, it is necessary you should reach to final state. We are only considering those paths which are moving from initial state to final state. No other path is useful, right? So here Q0 to Q2 we can reach with this path, or we can reach from Q0 to Q2 through this path. Even though we are having Q0 to Q2, if this will be final state, then we need to consider. But see, this is not a final state. Okay, see, I should write here Q3. This is repeated. Okay, so this is a Q3 state. So since this is a non-final state, okay, so even though with 0, I move here, I am not having any for acceptance of any string. So we can conclude that this NFA is accepting which language? L M is equal to only two strings 00, comma 01. So whether it is accepting a infinite language or a finite language, it is accepting only finite language. It is only accepting two strings. Apart from this two string, no other string will be acceptable by this NFA. Do you agree? Okay. Now, if I draw equivalent, now one more thing. What is the use of this path in this NFA? There is no use. Why? Because if with Q0 you move to this path, okay, you will be reaching to Q3. And if you get any number of 1, you will be keep on remaining in the Q3 state. Okay. Now, if you get any other symbol after Q3 as 0, no path is available. So finally, if you by mistake move from Q0 with a 0 symbol to through this path, you will be stuck up. Okay, you will be trapped, right? So, but if you move with Q0 with 0 symbol, this path, you are able to reach to some destination. That means you are able to reach to final state. So we can say that only this part of the NFA is useful to accept some language. I hope this is clear. Okay. Now when I am drawing equivalent DFA, so I could not keep this particular part. We will have proper methods for conversion for just showing you the power of two machines. I am trying to. So now when I will have equivalent DFA for this, it will be having only this much thing. It will be having only this much thing, right? So this is my equivalent DFA. Now if I want to know again same thing, what thing? Which language will be acceptable by this finite automata, that is DFA. So the answer will be again same. LM is equal to either it will accept 00 or it will accept 01, right? So for the above NFA, okay, the equivalent DFA is this one. Is it a DFA? Yes, because there is a single transition, right, to a single state. So here the language accepted by the NFA or the language accepted by a DFA is same. So we can say that if we have equivalent DFA of NFA, then it is having the same power.